Okay, this is the third part of our quiz review. So now we're down to quadratic functions used in geometry problems. So let's take a look at two examples. In my first example, I wrote out find two numbers whose sum is 120 and whose product is a maximum. So first I wrote out the sum of two numbers, which I don't know, so that's x and y. You can use any letters you want, but we're just usually used to using x and y. So I put x plus y is 120, and whose product is a maximum. So I put x times y. I'm looking for a maximum product. So in the first equation, I solved for y, which gave me y equals negative x plus 120. Then I need to take that and plug it back into the product, so I'll only have one variable in my equation. So that would give me x times, and then y equals negative x plus 120, so I plug that in. And the product, I'm looking for a maximum product. So then I just distribute so it's in standard form. And then I can use my vertex to help me figure out the answer to this question. So the vertex in this case, it always gives you x, but then think about what the total is here that you're calculating. That would give you the maximum product. So we don't need that for this question. It asks us to find two numbers. So once I get the x value of my vertex, I am just going to need to go back up here and plug it in and get the y. I don't need to actually find the maximum product. I can use it to check my answer, but I just don't need it to answer the question. So first I picked out negative b, which was negative 120, over 2a, and a was negative 1. So negative 120 over 2 times negative 1 equals 60. So that is x. All I need to do is take 60 and plug it back into x plus y equals 120, and I would get my y. So I'll put that over here. Just notice in the beginning of the problem, it might be a good idea to write out like what do they want you to find. So this one just said find the two numbers. So now I've got x is 60, y is 60, which would make sense because if you multiply them, they do have a maximum product. And if you add them, they do equal 120. All right, let's look at this second example. This one has a farmer that wants to fence in a rectangular pen, and he has 400 meters of fencing, and we wanted the maximum area that he can fence. And so we always set up a rectangle very similar to this one. We know that opposite sides are equal, and then if we only have 400 meters of fencing, we know that we have to take away the two sides we've already put in place. Then we also have to divide that amount evenly for these two longer sides of our rectangle. And then we know the area is length times width for a rectangle. So I wrote down area is length times width for what I've drawn over here. And I just wrote that very literally. I didn't simplify anything yet. And then I went ahead and simplified. Half of 400 minus 2x is 200 minus x. Then I distributed the x, and my goal here is to get it into standard form. So that again, just like on this problem, I'm going to use the vertex formula to figure out the answer to my question. So when I find the vertex, remember x is always what you find first. And then you could find the maximum area, which in this case, I do want to find that to answer the question they've asked. So I plug in negative b over 2a, which gave me negative 200 over negative 2, which is 100. And then if I plug that back into my function, where the area would be a maximum, I got 10,000. So to answer his question, the maximum area the farmer could fence is 10,000 square meters.